Hello everyone, welcome back to my channel. In today's tutorial we're gonna find optimal route between several points with Kepler.gl, which is a kind of map provider and map SDK. So yeah, let's dive into that. So the first thing that we need is just a bunch of pip installs. So we need to install geocoder, leaf map, which is again a map, Kepler.gl, which is the map itself. We're gonna use it to in fact demonstrate the map and to show the routes, points, polygons and line strings. GeoPandas, which will deal with in fact polygons and line strings, and Shapely, which is again a kind of library which mainly works with geometric objects and also polyline and Shapely. So first I'm gonna install them, which I already have installed them. And yes, they're all installed. And once installed, you can import all of them. So what we will import is leaf map from leafmap.kepler, GeoPandas as GPD, pandas as PD, and line string from Shapely.geometry. So we import them all. So let's see how the map itself look like. So in order to have the map, just the map itself without any in fact polygon or point or line string on it, so we need to just call this leaf map.map, and the arguments are center and the zoom. So the center is where the camera is at, and the zoom is the amount of zoom that we will zoom into in that center, and the height is simply the height of that map. So as you can see, so for this one, this is a specific one, the center is in fact in London, in fact the region park, and as you saw the amount of zoom was too much, it's about 18. So if we reduce it, let's say if it is, let's say 10, that would look like something like this, which is from above, but something around, I guess 40 would be good. So yes, this is the whole Regent's Park in London. So this is just the map itself, but as we go through the in fact tutorial, you will learn how to put points, polygons, line strings, and then calculate the routes from different points, and in fact having the optimized route and then demonstrate it on the map. So the next thing is just how to add a point. So we can easily do it with in fact GeoPandas. So first we can have a kind of data frame with longitude and latitude. So these are 2 points, 2 random points. You can easily find any points if you want to have add any other points. So what you can do is in fact just go to Google and search GeoJSON, go to geojson.io. So you can select any area that you like, let's say London again. So for example, in the case of Regent's Park, you can go to Regent's Park, and with this pin, you just need to drop a pin, let's say here, and you will have the coordinates. So you can add those coordinates into here. In fact I have 2 of them, and then once done, we will have in the first line we will have a kind of data frame which has 2 columns, longitude and latitude, and then we will use all those to change those columns into geometric points, which is completely another kind of object, which is useful in fact to demonstrate it and to show it in any kind of map SDK. So as you can see, we have 2 points right now, and these are point kind of objects, remember that, which is from in fact GeoPandas GeoSeries method. And by the way, remember that CRS is a kind of coordination. So this is the simplest coordination system, which is just long and let, which we can use it anywhere. And if you just in fact copy this and paste it into Google, you can see where that exactly is. So let me just copy that. Let's go to Google Map. But the only difference between GeoPandas and Google Maps is the order of lat and long is just reversed. So you need to reverse it, and then you'll see that it is exactly in the Central Park. So this is one of the points, and the other one, let's see where's the other one in the Google Maps, and then we will visualize it with Kepler.gl. So if I can just copy this. Yep, the other one is just in the middle of the Hyde Park, which is just several blocks away from Regent's Park. Okay, so now we know where are these two points, and now again let's use the map Kepler.gl to see where are they. Again, the height, zoom, and center are the same. We don't need this by the screen, it's not really important here. Let's run it. And yeah, as you can see, we have the same 2 points in the Regent's Park and Hyde Park as well. So this was how we can demonstrate and show a point or set of points into Kepler.gl with the add GDF method, which is geodata frame. But how we can also add a kind of line string into that. Again, in the case of line string, I pasted a line string here. So how to get a line string? Again, just you can go to this geojson.io, but this time instead of points. So first you need to delete this. If you want to have a kind of line string, you can easily just zoom in, and this time you need to select this icon and zoom in again. Then just click several times in order to have your line string. So as you can see, this is the line string that I want to have. And I continue to the end of this road. And once completed, just double click on the end point, and as you can see, you have coordinates of all that line string there. So you can copy that just like this one, and then once you have it, because it is just points, it is not a line string object. So what we need to do is feed it into line string method, which we just previously imported from shapely.geometry. So this would give us a line string object, just like points, but this one is continuous kind of object. So we add it into a variable called a and run it, and as you can see, here is in fact the circle in Regent's Park. So it is this one which I previously made. So again, having that, we can turn it into GeoPandas GeoSeries with this method gpd.geoseries. Again, the CRS coordinate system is 4326, and just like before, we feed it into Kepler Maple. With the first one is just initializing the map, and the second one is adding a layer, which here is in fact a line string layer. So let's call it line string, and then run it. And it's a bit small, but if you zoom in, you can see that exact line string over here. And by the way, you can also change the width of this line string here. So strict width, so as you can see, you can make it bigger or smaller with the sidebar panel in Kepler.gl, and so on and so forth. So in order to having several points and finding the best route for them, we need several things. In fact, we can have several scenarios. So mainly this kind of application is needed for delivery, like startups or ideas. So as you know, mainly deliveries deal with addresses. So we need to have the address, and then from address we need to have the points, and from points we need to optimize the shortest path and then travel through that. Like sending that to the delivery guy and travel with it. But the first question is, okay, if we have address, so how we can turn it into lat and long? It is easy. So you can do it with geocoder package, which we previously again installed it. So you can again import geocoder and then use geocoder.arcgis method. There are also several other methods like Google, Bing, I don't know, Mapbox, TomTom, so on and so forth, but those need API keys and they can cost you money. But this ArcGIS one is free, so you can easily use it. The argument that you need to pass is just the address. So here, this is the tower bridge. Just to quickly show it to you. It's over here. So the address is address of the tower bridge here. And what we want is, we have the address, we want to have the latitude and longitude of this pin. Run it, and as you can see, we have longer lat for that one. So again, let's go to Google Map and stop showing random images. We can install it, and as you can see, it is just the beginning of the start of the tower bridge. Cool. That's great. Okay, now what we can do is, again, feeding that into just making a data frame with that, and then GeoPandas, and then again show it on the map. So which in this case, as you can see, here is the place that tower bridge is just located, and this is our point, which is completely exact. So the first thing that we need to have for designing a routing is just a set of points. So with this specific one, this tutorial, what I'm using is just a data set which is open sourced in Kaggle, so every pub in England. So it is the location of all pubs here in the UK, and as you can see, it is name of it, the address of it, the postcode, lat and long, and a bunch of other features. So let's read it, and by the way, let's have a quick preview of it, how it looks like. So this is address, postcode, easting, nothing, lat and long, and local offer. And by the way, easting and nothing is again another kind of coordinate system, which is basically for the United Kingdom, but you can easily just change it into lat and long with 2 underline CRS method. Okay, so let's run it, let's read that CSV file. So by the way, I'm just using 300 of those locations, no more. And first I read it and then select the first 300, and then I change these two columns. In fact, lat and longs, this latitude and longitude, into numeric, because in the original CSV these are in the type of a string, and I don't want to have a string. So let's have a view of how it looks like. So yeah, this is how our dataset looks like right now. So then let's just, in fact, visualize all those 300 points, how they look like. So zoom out, and as you can see, here are 300 out of 51,000 pubs in the UK. So what we want to do next is to find the best route. Imagine that we want to have a delivery for all these points. So what is the best and optimized route for all these locations if we want to deliver to all of them? Okay, how we do it? In fact, the answer is simple. We do it with OSRM, OpenStreet, in fact, routing machine, which again we can easily go here and OSRM. So this is the documentation for it. If you want to know and understand it in more detail, you can just go and have a look in the, in fact, website itself. There is the full documentation, and yeah. So what we need is, in fact, we need to have an API call to this, in fact, OSRM API. So this is how it looks like. Just let me grab it and then paste it here. So this is the root project, osrm.org, root v1 driving, and then the location of the, let's say, deliveries or addresses or whatever they are, lat and longs. And this overview means how we want, so once we have the route, optimal route, we need to, in fact, demonstrate it, to show it. So how it should look like, with full details, all the route segments piece by piece, or just a kind of estimation of it. So here I just say the overview must be full, which is with the best and most accurate, in fact, accuracy, and it will give me the geometry, which here geometry means that the route itself, the optimized route. But by the way, so why it looks like something like this, it's a kind of trick. We can say that geometry should be kind of point or polygon or line strings, as we saw here earlier, for example, on this one. So yeah, something like this. For example, line string like A should look like something like this, or the points also are kind of geometry, should look like this. But why geometry, which is again here, is a kind of line string, why it looks like this? So in order to have a easier, in fact, put it easily into a kind of JSON, we turn all those points or line string, or let's say generally geometries, we encode them with polyline encoding, and that would give us a kind of just a string of this form, which is really useful. So if I just copy this and say in Google, if I say, let's say polygon, I think encoding, the Google one, so it will give me this website. And if I paste all that polygon here, and then decode that polyline, you will see magic. So this line string, in fact this string, which is geometry, will be this, with all the location and in fact all the lat and longs. So we will use this API, but what we need to do is putting, in fact we have, let's go back to our problem, main problem. So we have all these locations. We need to put the lat and long of all these points, embed all those into this URL, which we are going to do right now. So let's just quickly run this one. So you can, by the way, this is how it looks like in the browser, but if we want to do it in Python, so we need to first import requests, in fact library, and then the URL that we want to call it, which is exactly the same, and then we in fact call a get method on that URL, and then we will have the result. We will make it kind of JSON with that one, and then in order to extract this specific field from all that JSON, what we need to do in fact is we need to go to roots and then geometry and select that geometry, which is exactly what we're going to do here. So encoded polyline should be this one, which I just run it, and yep, that's how it looks like. So after having this, I need to turn this line string in Python into these, in fact, lat and longs. Again, I can do it with polyline, which it has a polyline package, which it has a kind of method called decode, and I can give polyline the encoded one into this method and then get the decoded version of it, and then again I will change it into line string and then visualize it. So this was the end result, and see how it looks like in Python. So the first part and the second part. So I think this example is in Berlin, so let's go to Berlin. If I can find it. Yeah, here it is, just right here. So you can see the line string right here. Just let me make it a bit bigger so you can easily see it. Yep, here it is. So now we want to find the optimal route for all these locations. Again, we check. We need to put all these points, the latitude and longitude of all these points, into this URL, and then call it, get the geometry part. Once we get it, it is a line, in fact it's a encoded string, turn that encoded string into decoded polyline and then visualize it. Okay, so we will define a function which will, as an argument, will receive the path, and the path is the path of this CSV. The URL will be empty for now, just empty line string, empty string. Then we will read that file. For here I choose, as I said, 300 of those locations, then change the type of latitude and longitude, which I said, as I said, it is a string, so I need to turn it into numeric. And then once done, I will go through each of those lat and longs and put them one by one into this URL variable. And then once done, so I will have a kind of this URL right here, and with this URL, in fact, braces column -2, I will put all the locations which I extracted here from the data frame. I will embed all those into the URL and then call it, turn it into a JSON, then get the geometry part. From geometry part, I will decode it, because what I get from geometry part, it's a string. Then I decode it, and once decoded, I will extract all those effect points and then turn them into GeoPandas data frame and then visualize them. In fact, return them and then visualize them. So let's run this script, this function, and then I will give this effect file, and let's see how the root looks like. So there's just a line string, and we can give it into Kepler mapper to see the result. So yeah, this is how it looks like. It's a bit messy, but this is exactly how it should look like. So if I again go back to the points, so these are all the delivery points which we need to do the delivery, let's say, and this is the optimal path for it, which looks really cool. Yep, that's it for this tutorial, and see you on the next one. Make sure to like and subscribe. Thanks.